1.2 billion people suffer from fungal infections every year. That's the entire population of Africa. 1.5 to 2 million people die from these fungal infections. That's the entire population of Manchester wiped out. Now, usually these people are immunocompromised, which means that their immune system isn't as good as it should be. They can end up with conditions such as aspergillosis, caused by Aspergillus niger, which I'll go on to talk about in just a moment. Now, when I'm talking about fungi, I don't just mean mushrooms. I mean all multicellular organisms that are very similar to us, but are called fungi. All mushrooms are fungi, but not all fungi are mushrooms. So this is Aspergillus niger, which is commonly known as black mold. You'll find it in most student accommodation. It can cause conditions like I mentioned earlier, aspergillosis, which will affect your respiratory system. Usually affects people that are immunocompromised with conditions such as COPD, which is a lung condition. And this is tinea pedis, commonly known as athlete's foot. Another one you'll find in student accommodation. It's pretty grim and is known as a dermatophyte, which means that it can affect the skin, and it's usually found there. Quite easily treatable, but some studies have found resistance already rising in them. And then we've got Candida albicans, or thrush, which can cause conditions such as candidiasis, and that is found usually in warm, wet environments. There are 5 classes of known antifungals, constituting up about 20 or so drugs that are commonly prescribed for such conditions. They only work on 3 main mechanisms of action. So they either impair cell wall synthesis, which means they stop the outside of the cell being built, or stop it being built as well. And then we've got they completely stop the building of the cell wall, and completely just stop it and cause cell leakage, which means the guts of the cell spill out everywhere and effectively kill it. And then we've got drugs such as nucleoside analogues. They affect the DNA within the cell, much like ours, which means that the drugs, there can be some interaction with humans, which means they're going to have an awful amount of side effects, which is why they're so limited. Now, my research here at the University of Lincoln is around plant extracts as novel pharmaceuticals for antifungals, or as antifungals. Now, you might not think there's a lot of plant compounds that could work as this. Well, I'd like to give you a few examples. So we've got nicotine from the tobacco plant. Some of you might have had some nicotine today. It's fine. Or we've got morphine from the opium poppy. Or atropine from deadly nightshade, which is used in some heart conditions. There's aspirin from willow bark for headaches. And then there's everyone's favourite, caffeine, which I have had quite a significant amount today. Now, I'm working on mainly herbs that you can find in local shops or garden centres, such as thyme, or Thymus vulgaris. So the literature has already shown that thyme, or chemicals within thyme, such as thymol, work by entering the cell and inducing cell leakage, like I mentioned earlier. It can also break down from the inside the cell membrane, which also helps other drugs pass through the barriers of the cell and kill it. And then there's garlic, which is by far my favourite. Everyone loves garlic. Now this is some pretty lethal stuff. This will get into the cell, break down the cell wall, and individually take out the components of that cell. Every single organelle or bit, such as the mitochondria or the nucleus or the DNA, all of it ruined by garlic. It's great. And then we've got licorice, which increases cell membrane permeability. So that's the wall around the cell suddenly has loads more doors in it for drugs that I mentioned earlier to enter in through and to take out the cells, which would reduce the amount needed, so it would make it cheaper and would mean there would be less side effects to the person taking those medications. Now, while there are all these institutes working on antifungal research around the world, there are some things you guys can do at home. Okay? We need you all to do this to help combat resistance. So let's stop using hand gels. Please, please stop using hand gels. You can use any other sanitizer as long as it's not in a gel. The Well, alcohol does kill most living things on your hands. So at 3%, it will kill out most yeast, most fungi, quite easily. 70%, it will wipe out pretty much all bacteria. But the gel is a food matrix. It contains carbohydrates, proteins, everything a cell needs to survive. So you've wiped out all of the lovely friendly flora and competition on your hand with that hand gel, the alcohol in it, and then given it a food matrix. And you think you've got clean hands, that you're going around touching everyone, shaking hands, all of that, and you've just pretty much eliminated all competition needed. And you could have anything growing on your hands now. Which brings me to my next point. I would like to eradicate handshakes. There has been a couple of studies done that say this is the best way to transfer pathogenic bacteria, which means it can infect humans. Now, as I mentioned before, if you've just used hand gel and you've got a lovely food on your hands and you go and shake someone's hand, you could have taken something to them or got something from them. So instead, we're going to fist bump. And in a few years' time, you'll be fist bumping your boss, and it'll be great. And the last one, which seems like a really obvious one, and I don't want it to come across as patronizing, but please wash your hands. Just warm water and soap. Soap is a fabulous thing. It doesn't need to be antibacterial or anything like that. It works by binding to the cells, the cell membranes, the proteins that hold it onto your skin, and completely removing them and washing them away. So it doesn't kill it by any stretch of the imagination, but it does remove it from your skin, which is great. If you've learned anything from this talk, is that perhaps we're not all doomed after all. Thank you.